Welcome everyone. So I am Kunal, and I am now will continue the topic AC to high voltage DC from the subtopic methodology and principle. Before this, my friend has explained the things, the basics. Now it's the time to understand the real and the main important thing in this topic. So let us start by understanding the principle of the AC to high voltage DC converter. So let us read the principle. The circuit uses the principle of charging capacitor in parallel from the AC input and adding voltages across them to obtain the high voltage DC. So it is saying that we have to connect the capacitors in parallel. Parallel in the sense that they do not connected in directly. This means that one end of the capacitor is not directly connected to the other end, because in the figure you can see that the capacitors are not perfectly connected in parallel, because there are also diodes in between them. So parallel just basically refers to the thing that we have to first connect the capacitor and then a diode, and then a capacitor then a diode. The combination of these diode and capacitor basically uh, contributes in the formation of a stage, and if we increase the frequency of these stages, then that results in the conversion of high DC voltage. If we are using two stages, then it will multiply the DC voltage, AC voltage, and convert into DC voltage by 2 times. So for example, if we are getting the 12.7 volt, here you can see it is a half wave voltage doubler circuit. So half wave voltage doubler circuit will multiply the AC voltage 2 times and convert it into the DC voltage. So let us try understanding the half wave voltage doubler circuit. So basically, first we will go through the apparatus using. So first, the main thing is the 220 volt AC step down transformer, which you can see here. So this step down transformer is used because there are two reasons of using this. The first reason is that if we use a step up transformer, then the high voltage cause damage in the diode, because a sudden high voltage may get may the current will flow through the diode and may get damage the properties of it. The second thing is that using low voltage AC, I mean step down transformer will result in low voltage AC. So because we want to start from lower ranges like 15 volt or 30 volt, in the example we can see the 12.7 volt is the V peak value. So V peak basically refers to the, since the voltage is AC, so it may variable as sinusoidal wave. So the highest voltage we can get from the AC voltage source is V peak. So that term refers to the V peak. So basically we want to start from lower voltage range, and according to our need we will increase it by increasing the stages in the AC voltage, AC to high voltage DC circuit. So for low voltage DC we are using the step down transformer. So let us now move to the depth of the understanding this circuit. So firstly, let me tell you that the sine wave of the AC voltage is the most important thing here, because this will decide whether which capacitor will charge or which capacitor will be discharged. So let me just draw the first positive half cycle. So this is the first positive half cycle you can see here. During this first positive half cycle, the transformer polarity is like that. Here it is plus and here it is minus. So all of us know that current will flow from this direction. Now this diode will be in forward biased condition, and this will be in reversed biased according to the PN junction properties. So the current will flow from this direction to this. So this is the pattern of current flowing direction during the first positive half cycle due to the forward biased condition of the diode D1. So this will result in the charging of the capacitor C1. So this capacitor will get charged because of the flowing of current, and it will be charged up to the maximum possible voltage, that is the V peak. V peak refers to 12.7 volt here. So now during the next During the second negative half cycle, you can see here, uh, this is the second negative half cycle in, sorry, negative half cycle. So this is the first negative half cycle, you can see. So during this half cycle, the polarity of transformer will be like this. This is positive and this is negative, and this diode will get forward biased, so current will flow only through this path and not this, because this is a reversed biased diode, so current will flow through D2. Okay, so as it will flow through D2, the C1 capacitor will act as a battery and the transformer will also act as a battery. Now you can see the polarity of these batteries result in the series of two batteries. So this is like, here I am drawing the circuit. This is C1 battery, consider it as C1 battery, and this is transformer's battery, and these will charge another capacitor, that is C2. Sorry, so these are the battery. This is V and this is also V, so both have the same polarity, so this will result in the formation of 2 volt, and the capacitor C2 will charge to 2V peak. So this is, in this way the voltage multiplier circuit work. So this is all about the hypothetical situation I was talking, and actually in the real situation it will take some more few cycles. So let me quickly uh, tell you that how it will take a few more cycles. So let us go back to the first positive half cycle. During the first positive half cycle, capacitor C1 get charged. Okay, so after charging of this capacitor, during the next uh, negative half cycle, or the first negative half cycle, the transformer will not work as a battery. Instead, only this capacitor C1 will work as battery and will help in charging of this capacitor C2. The current will flow in this direction and this capacitor C1 get discharged and capacitor C2 will charge to V peak. So during the negative half cycle, the capacitor C2 will charge to V peak and this will get discharged. Okay, so in the next positive half cycle, like this is the next positive half cycle. During this, again the transformer polarity is like this. So this will result in charging of capacitor C1, diode D1 will be active, D2 will be inactive due to reversed biased. So this will help in again charging of C1 to V peak. Now in the next negative half cycle, that is this. During this negative half cycle, the transformer polarity will be again, this is the next negative half cycle, and the transfer polarity will be like this is minus and this is plus. And now this capacitor is C1, so this will charge the capacitor C2 again, because capacitor C2 is already at V peak, it is not discharged in any of the half wave, positive or negative. It was charged in this first negative half wave, but now in the second negative half wave it is again charged, but this time it will not charge to v peak, but already it is to V peak, so it will charge to some more extent which is less than 2 V peak. So this is, in this way, in some more few cycles it will approximately be charged to maximum to 2 V peak. So in this way the capacitor charges. So this is the real situation, but let us only remain at the hypothetical situation because it is easier to understand. So now let us move to the, so these are the operating steps you can see here. In positive half cycle, D1 get forward biased and C1 get charged through D1 up to V peak. In the first negative half cycle, D2 conducts and D1 reverse biased. D1 blocks charging of C1, so only C2 will be charged to V peak, and this time it will charge to 2 V peak according to the hypothetical situation. And in the second positive half cycle, capacitor C2 discharged into the load if load is connected. So if there is load, then it will get discharged in the second positive half cycle, So we can see that in one charged cycle, it is discharged, and in the another cycle it get discharged. So this is the all about first half wave doubler circuit. Now we will look at the full wave doubler circuit. So this works a bit differently from the first half wave circuit. So here we can see we again have to draw the graph for the sinusoidal voltage wave of AC current. So this is the first positive half cycle. During the first positive half cycle of the current, the transformer will be polarity like this. So only diode D1 conducts because current cannot flow through this direction, because D2 is not the in condition to allow the current to flow. So current will go like this. So current will go like this and move through this direction. Note that it will not go through the C2 direction from here to here, because C2 is initially discharged and D2 is also there, so there may be some sort of resistance, so it may not go to there, and it will choose the shortest path to complete it circuit. So it goes to the D1 and then move through this direction as I have shown. So in this way C1 get charged to V peak. So in the next negative half cycle, from this to this, there is negative, there is positive, and come to this. In this way it will flow. Again see the current direction, it will go like this, charge the capacitor C to go through the diode D2 and then come again to the transformer. So this is the second way of in the first negative half cycle it will charge C2 like this up to V peak. So in this way we will get the V peak as the resultant voltage. So let us quickly understand the half wave tripler voltage circuit. So let me just quickly draw the sine wave here. So this is the sine wave we have. This is the first positive half cycle. So during this cycle the only diode D1 conducts, also the current, although diode D3 also conducts, but since the capacitor C3 is discharged and there is no potential difference in there, so the current will choose the lowest possible path to complete its circuit. So it will go like this, because the diode polarity is like this, plus minus, in the first positive half cycle like in the previous examples. So in this way the capacitor C1 get charged. So capacitor C1 get charged, so let me mark it by red. So the in the next half cycle, that is the first negative half cycle, the transformer polarity will be like this. So only diode D2 conducts, so it will charge the capacitor C2 in the same way as we have seen in the half wave doubler circuit example. It will take the voltage of C1 also, and the transformer also act as a battery type. So these C1 and transformer polarity will act as two battery in series and will charge the C2 to 2 volt times peak, I mean 2 into V peak. So this is the way in the first negative half cycle C2 also get charged. So C2 also gets charged. So now in the second positive half cycle, transfer polarity again like this, and in this way D1 D3 conducts. So now what will happen here, you can see that the current will not charge the transformer current will not charge the C3. Instead of transformer, capacitor C2 get discharged and transfer its charge to C3 like this. In this way you can see here, it will go like this, current will flow like this. Okay, so it will, according to the forward bias condition of diodes D2 and D3, so it will go like this. Or we can also understand, as I have already said you, that D2 will not work in this condition of polarity of transformer. So we can understand the circuit as like this. Let me just draw. This is capacitor C1, and due to the D1 act as short circuit, D2 act as open circuit, capacitor C2, sorry, D2 act as open circuit and capacitor C3. So it is again open circuit. So now you can see that the current can easily flow through this direction. Okay, so in this way capacitor C2 will charge the capacitor C3 up to 2 volt peak, and already capacitor C1 is charged. So C2 is 2 V peak and C1 is 2 V, only 1 V peak. So all these will result in the 3 V peak resultant. So in this way voltage tripler circuit work. As I have already told you that this is in the hypothetical situation. In the real world it will take some more cycles to maintain the voltage up to 3 V peak. So in this way we can see that the working of the AC to high voltage DC circuits. So now let us move to the block diagram. So these are the block diagrams you can see here. So this is the, so here we can see that the transformer is the first part, and then the rectifier. The rectifier will, this actually this is the graph for the full wave rectification, as we can see here, because in the half wave rectification the graph is like that. So this will, so this graph is for the second example we have seen, that is the full wave voltage doubler circuit. So this is for that. So after rectification, smoothing is done. Rectification is done with the help of the capacitor also, because the capacitor act as the filter component. It will help in making the AC component vanishing, which is we can see in smoothing. Rectification basically is can also alone done with diode, and we will get the resulting graph. But when we use the capacitor in this smoothing part, then we can convert the voltage into this type of graph, because the capacitor will take the AC component as capacitor reactance. We can see for DC, let me just change the color. For DC frequency is 0, so omega is 0, hence and I have already said you that for DC the capacitive resistance will be Xc is equal to 1 upon C omega. So omega is 0 and it will result in infinite resistance. So this will not, so only the DC component will flow through the circuit and the AC component will go through the capacitor, and in this way we will get the regulated voltage in the filtered output. That's why when we add capacitor in a circuit, we say it as a filter circuit. Then we will move on to the regulator. Regulator again helps to maintain the constant voltage, and as the load the voltage is used. So this is the block diagram for the rectification from AC to DC. So now let us move to the next block diagram. So this is the block diagram for the voltage multiplier circuit. So we have used the transformer here, then X number of capacitor and diode network for X times voltage multiplication, then DC voltage regulator and R load. So important observations we can see here are the a voltage multiplier specialized circuit producing output which is 2 to 3 or 4 times the AC peak input according to the capacitor and the diodes we have used. Voltage multiplier often give low currents because as we increase, because power is constant. So power is constant, so if we increase multiply the voltage, then it is obvious that current will decrease. Okay, so due to the constant power, the current will automatically decrease for high voltage. And look at this point, the voltage will not multiply straight, but it will take some, as I have already told you, that it will take some more cycles to in the real world to completely get that much voltage which we are seeing in the hypothetical situation. So the calculation for output voltage, for a voltage multiplier output voltage, you can see the formula here. So this formula is basically derived from the, as the multimeter reads the RMS value, So we have to multiply root 2 into it to get the peak value. So n is the number of stages we are using, root 2, and then V in, that is the voltage which the step down transformer is provided. So after this we have advantages and disadvantages. Advantages of this, obviously advantages are more as compared to disadvantage. That's why this technique is used usually in the industries. So advantage, it is has less space, low cost, it is handy. It will generate high voltage. By increasing number of stages we can generate a high DC voltage, and it can replace expensive and heavy transformers. Yes, because a step we can use it in place of a step up transformers. So the disadvantage are that, first disadvantage is saying that, practically we do not multiply the voltage to infinite because of the capacitor and other factors, because the capacitors must have some capacity. So according to that capacity we are working with them. So those capacities have to be kept in mind when we are multiplying the voltage. Otherwise, the capacitor will be breakdown and the diodes also get breakdown. So these are the advantages and disadvantages we can see here. Applications are in microwave, X-rays, laser systems, and Cockcroft voltage generator. This is the type of voltage multiplier circuit with arbitrary length. This means there are n number of stages in automobile manufacturing industries, etc. So the conclusion for this topic is that, the voltage multiplier circuit is only advantageous to us. The only problem with the circuit is that the rippling factor. Because of the rippling factor, even after using a filter circuit, there is some AC component which get remain in it. So this is the only problem we have. Otherwise there are only advantages, and some other problems like low current factor and capacity and diode cost. So these are some other problems, but overall in the long run it will result in some beneficial situations. So now we have completed this topic. So thanks to the Saurabh sir for giving us the opportunity to present our views on this topic. So thank you. Now I'm ending the video.